Okay, so recording is up. Welcome to the Tools Team workshop at the start of February 2024. As usual, the first Friday of every month, I would like to roadmap of what we had been solving in the last period and also we plan to do. So there my browser view, and let's start from our team, how we work closed the tickets that were closed. So in the last 30 days, in total, we had 68 tickets. And out of those, we had 18 OpenGA feature requests and minor regressions of crashes that we worked on. And then roughly the other half is infrastructure and other projects. That by project, then we also see the ratio there. So we have 23 tickets in infrastructure, 29 in the OpenGA project, 2 in the test project where we support or add tests ourselves, 9 in the generic QA project for internal, and 1 for the operation talk. Out of those, we can take a look. We had, for example, a problem in the internal deployment, which was mostly how the packages that we're installing are computed by the build service or the download infrastructure. Things like this happen. In some cases, we apply workarounds or trying to find better means. Here, I think we forcefully re-triggered a rebuild in projects, and then new versions of the package were fine, and then they were deployed. Next one is that there was a problem with progress OpenSUSE.org, which created 2 new versions affected us, and quickly see that based on all the automation scripts that we're running, where we are affected, but also there we didn't do much on our side or just monitor the situation for that somebody else or some other teams could already solve that. Didn't invest more. And actually that one is related to that as well, where we have the fetch OpenGA bugs script. So this is the one which updates the OpenGA internal bug references. You know this bug icon, which can be upside down and red when it's solved. So those updates, they happen by this fetch OpenGA bugs entity, and that one was not able to access. But basically that by awaiting a fix on that extra. We also observed problems of an HTTP response alert that was somewhere during the middle of the European night. It probably didn't affect many, or you wouldn't even have realized it. We saw it on our monitoring, and yeah, also there our investigation didn't reveal anything actionable, so they saw that the problem also resolved itself, and then we didn't invest more effort. Another example is where we did need to invest some effort is that we were receiving a file system alert, and one of the file system was too full. I can also show you how that would look like. So when was that? That was like that happened 9 days ago. So we have Grafana with our monitoring, and if we are taking a look back the last 30 days, then how we are monitoring the file system there. And as you can imagine, this is about the green one, that's assets. And you could see that some point around the 20th of January, there was a steady increase where commonly a cleanup should help to remove more assets, but this is depending on the settings in job groups that you as test maintainers can also choose and tweak. Up to this point where it's triggered an alert. The alert is at the threshold of 90% usage of the file system. And that is alarming because OpenQA already internally, as you can see here, really tries to, keep the system on that level. But actually what we have configured OpenQA for is to keep the level of 80%. And you can already see that for the complete month of January was already exceeding 80% by much. OpenQA did what it could do, but again, as I said, this depends on the settings. So, and then what we did to mitigate that situation is we went over various job groups settings, reduced those settings, triggered explicitly the asset cleanup. So you could see how OpenQA was steadily increasing the space usage so that we were actually below the limit of 80% again, however, not by much. So we also coordinated with IT to have an increase of the assigned storage available, and that's becoming effective here, where you could see that, by increasing our storage by some terabytes, the actual usage dropped to 60%. And then actually very quickly, the usage on OpenQA was again rising to 80%. But that's not a problem because we only ever trigger an assert cleanup when we actually reach 80%. And then assets were cleaned up, so back to that level. And then from then on, we have a lot of headroom that should last for some more months. Next, other alerts, for example, for an S390 instance, we also had memory usage alert. Actually, there the same thing was done, but for memory. So we looked into the system and we found that the amount and the size of the virtual machines that are scheduled on that instance can exclude the assigned memory. So we selected to look into both alternative approaches in parallel, which is to reconsider the amount or the size of virtual machines to schedule on that host, as well as coordinate for an increase of memory on not only this S390 instance, but also the second one, which has the same purpose. So that was also done so that now also those machines have more memory. We supported another squad to get a backlogger running. So let me show you as a daily work tool. What we do is we are using a backlog status view, which is this one, which normally shows all green hearts, and when it ever shows up any red bubble, like it does here starting today, then we will look into mitigate this to ensure that we can stick to the process that we have defined for us. So this really helps us, and we see also other teams adopting that. So for example, the SUSE QE YAM squad was proposing to add their own according queries for that, which is then triggered on YAML files, which define which queries and which data sources to access. And that was not necessarily straightforward, but in the end turned out to work fine. So this is where we, let's see. Right, there was a problem in December last year with a proxy, and which is test system used to proxy access to SEC for testing purposes. And in the process, the service was migrated to a new platform. Before it was a virtual machine. We could actually ping that. And now it's a service which doesn't enable us to do a ping check. And what we did instead is that we changed this HTTP based check. So we are checking the actual success of an HTTP response. So I can also show that how this looks like. So we had already in before a check, for example, where we would check that the web UI is responsive, and here we are checking this and other external services. So let's take a look how it looks like. Yeah, so here you can see that we are checking for proxy /API/hash/status. So we're checking with the knowledge of this API endpoint. We are checking that external service if it's fine and the state is normal. So it's comparison for OpenGA SUSE QE. There is also a route called health. I mean, we are checking tests as well. This is a more heavyweight page, and health also defines the internal health state service. So let's check how that looks like. Very simple. So you can see that also OpenGA SUSE QE defines the and this is monitored. Yeah, when working with that system, you realize that also Grafana is rather fast moving. So it can always happen that there's some new features introduced and old features deprecated. So we saw that on some panels, there's a mention of deprecated Angular panels. So, we also needed to create those. So now we are set up properly again. OpenGA, the upstream OpenGA project is using Virtual CI as a main CI system. Well, we already had that problem in the past, and that we appeared with a similar shape, running into a timeout to slow download from registry OpenSUSE.org, which could be for various reasons, but we handled that one here better. Actually, the way we did handle that is by shifting the time when we conduct a daily or a nightly test run there. That seems to help. We're also setting up new machines, and one machine is one that was rather recently requested for manual bare metal testing on the ARM architecture. So we already set that up. Actually, it says set up for tests in OpenQA, but here we mostly use OpenQA to verify that this machine can be used the same way as other machines for bare metal testing. But of course, from then on, can be used for automated testing just as well as for manual. Yeah, we are now in SUSE having multiple data centers, and then what we observed is that there was, for us, unexpected thing, which actually after clarification, it turned out that everything is as it is expected. We just clarified that because it has an impact on, when we are crossing data centers and there's a tunnel between those data centers, then also the MTU size is affected of what you can actually do when you're doing multiple layers of network traffic, working with multiple machines within one data center or across multiple data. So think about OpenGA multi-machine tests. We had a situation where sometimes we want or we did have tests across multiple data centers with, unexpected effect. That's what we have the word here. We have a much better understanding now, and we could prevent such a situation to happen. Plus, we also could fix the case when it actually is necessary or would be necessary. Yeah, more ARM servers, more S390 space usage, more multi-machine, all that. So that for the OpenGA infrastructure. Now for the OpenGA project. Okay, this was a support task. How to cache wheel repositories which are stored on Git. That one I would like to highlight. It was meant as a research time block task, but then it turned out to be pretty big. So in the end, we did manage to add a new feature to OS audience. And what that does is basically adds one variable, which is called the git cache dir. And with git cache dir, what that means is whenever you clone an OpenGA job or you trigger an OpenGA test, which you could already do for years pointing to a Git repository, then this Git repository cloned and used within the ISO2 video run. Now, if the git cache dir is set, that's a variable defined in the scope of OS audience, then local caching is attempted and conducted. Meaning that if the Git repository is not there in the cache yet, then it will be put into the cache and from there. And if you run the test again, or if later on you run a similar test pointing to the same Git repository, not necessarily the same branch, but the same Git repository, then the same cache dir is used and the content is accessed from there. And I wanted to highlight that because this is in a bigger context about formerly was part of the saga about full version control awareness, which that feature enabled us to progress further. But I just yesterday, I reworked the structure a little bit. So I split out another saga. I will come to the version control awareness saga again when talking about the current roadmap. But what is a potential follow-up for later, better shareable OS audience and test distribution plugins. So for example, to enable better maintain individual parts of big test distribution, Git repositories can be used in OS audience plugins called fields. And for that, the caching is an essential feature to make that an efficient approach. Related to that, we also have more work that will come up in the next week. Also related is that ensure cloning OpenGA jobs with cache dir works in user cases. So that, for example, if a test was running on a worker with git cache dir, but then you clone it, let's say, to your instance, maybe you never configured the git, why should you? Then also the cloning should work, and we ensured that this properly works. Now something completely different. Test OS audience and OpenGA against SUSE backwards SLE in pull request. Now you might have seen, let me just pick any latest pull request in OS audience, and the same would apply for OpenGA. There we have multiple checks, including OBS check. So we can find here in details that we are triggering tests on OBS. We are triggering not only the build, but also the tests within, which are defined within the spec file, plus the actual test packages for various sub-packages. And you can see that we now do that for 3 distributions: Tumbleweed, current released Leap, and current SLE in development plus the backports, also called package up. So with that, we are ensuring that everything we do within OS audience and OpenGA is possible to be built and usable on SLE base, including package up. Why do we do that? Well, we already had for years, let's say, the kind of a best effort support for SLE, but we wanted to streamline that. The bigger context for that is the saga, which in our next stage, OpenGA for SUSE customers, where there are plans to ship OpenGA as part of a bigger SUSE product offering, and hence we want to provide OpenGA on a stable operational system base with long-term enterprise. for that one epic is that we want to have OpenQA on Sleep plus package up. Now, plus package up serves good use cases for some customers, for some use cases and some customers. But the next step after that is to actually have OpenQA on pure Sleep without the need of any unsupported packages. And that's also. Now let's see some improvement for the CI. Ensure proper white space in all audience scripts. It's actually more than it might sound, because what we did is integrate a shell formatting static code analysis tool in multiple repositories within the OS audience ecosystem so that we can benefit from that. Also, whenever you would create a new test distribution and you would use one of our distributions as a template, then you would also could also make use of this feature. Yeah, I mentioned the backlogger and the QA Tools backlogger system, showing the status overview before. Now we actually also have enabled a notification so that we have a note on our team internal chat channel whenever the query is exceeded, when a red blob shows up, but also if the problem is resolved, which is really cool, helpful. So I will skip over some. Like to mention some important. For example, this one. Over the past months, we were becoming more sensitive regarding multi-machine test failures. So we are closely monitoring the stability of tests, and in many cases now we are triggered ourselves by alerts, and then we take a look for the reason. In some cases, we are still triggered by users where we didn't immediately see a problem in our monitoring ourselves. In any case, we take that seriously, and we are trying to identify what the problem is. Often there are various reasons, various different tests, and might need different handling. The key important part here that's related to the unexpected routing between data centers, which I mentioned before, is that the MTU size that we can use is limited or was limited. This is which we mitigated by multiple ways. One would be to actually set an explicitly peaked MTU size within OS audience distro OpenSUSE, which is more resilient, so lower value, which might have some performance impact. Figured that for all those multi-machine tests using that, it's not a problem. And because the resilience is more important, we would like to have a higher MTU size, and now configure that with a test configuration variable easily. Plus, what we did is that we actually constrained the worker so that we have multi-machine clusters only staying within one data center at a time. So you wouldn't have that situation across data centers. What else? Run OpenQA tests and pull requests. So that's a very important part, also related to talk about full version control awareness. What it means that if you are a contributor to OS audience distro OpenSUSE, every pull request is tested live on OpenQA and according feedback is provided. So let me show you. Actually, we can pick any example here again. So for example, why not just pick the latest pull request that is currently open? And what you can see here, all checks have passed. What are those checks? There are various checks. There are some static checks. There's running the video test. And there's also a real OpenQA test. It says basic OpenQA because the scenario that is used there is what we selected with primary objective to be very quick and very stable. So that's simple boot snapshot scenario. You can see that overall took 2 minutes and 37 seconds, running boot to desktop and boot into. Now, whenever you touch those areas of the code, then this is a pretty good test. Like, does the system actually still boot your changes? But of course, if you're changing something in a leaf area like term, then your changes won't really be covered by this test. This is why what you can do now, you can use this test and clone it and to parameters accordingly to select a different schedule, for example, with the binary definition YAML or the also the internal YAML file for the schedule, or by setting the test variable to specify the module. Of course, you can also clone any other production job and set variables accordingly as usual with the OpenQA clone custom git ref spec. There is more work planned related to that as part of Epic, trigger OpenQA test and pull request of any product getter pull request. You might say this is already covered because that's what we have. Because we do trigger OpenQA tests in pull request, but there are some more ideas to rule out the rough edges. For example, that you can ask OpenQA to run with specified test parameters by putting something in your pull request. Like, for example, when you mention a certain job to clone in the GitHub description, or if maybe not you as a test author, but as a reviewer, you want to ask OpenQA trigger certain OpenQA tests as verification ones for this pull request, like another job. So you could say, hey, OpenQA, please also test this pull request against that. Yeah, and also what we identified is that what we are doing there, for example, in our audience history of SUSE, we are picking the latest tumbleweed image that's available on OpenSUSE.org, and for that we are asking OpenQA itself over API. And that's possible, but you know it's a bit longer command line with multiple calls to JQ and type parameters. And it's actually not using a stable API. So what we want to have is a last build API for any kind of product directly accessible over the OpenGAP API. Would be, which was motivated by. Allow to serve tests by comments on the UI size. I do not want to go too much into detail about that because we have a separate workshop session planned for this one. So if you're interested to learn more about this one, then please come visit us week after next week, February. Allowed to search for tests by comment, which is else. Oh yeah, we have automated OpenQA tests to verify that we are actually having valid multi-machine test setup by a script. So that one I would like. Because what we see, what we have there is, you might already know, we test OpenQA in OpenQA, right? For example, here the latest build was 35 minutes, and this has grown to 6 scenarios by now. So the latest addition is this one, OpenQA install multi-machine. And what this one does, that actually a single machine test, so it's a single test, but what it does internally, and that's the interesting part, is that internally it's starting multi-machine test within that OpenQA instance. And then checking on that scenario. So you see here, two jobs have been created, ping server and ping client. So two tests in that internal instance. And then we are checking for those jobs to complete. Let's jump and I guess, yeah, here, right. So we already see it passed. So we are looking for those tests and they pass, same as in the single machine scenario. So, we could actually run a multi-machine test within the internal OpenQA installed as part of test. And that shows us that, we can actually run a multi-machine test scenario where one machine can ping the other. What else? Well, related to that, we also extended and added more validation step and best practices for multi-machine debugging in our documentation. So that pull request, we see some additions, how you could do more or less what this OpenGate and OpenGate test is doing with simple ping, check, or wicked basic test scenarios. And more. This was one of the pull requests, and there were others as well. So actually, you go to the OpenGate documentation, and let's multi. What is left to multi-machine? What also does, and then verify the setup. So here you can, after setting up multi-machine support in your OpenGate instance, there's a section verify the setup. Simply run scenario for user. You can find many relevant tests for network related tests like ping server and ping. And that's one neat example showing you how you can clone that cluster. By the way, this is also a nice example showing you how you can one single OpenQA clone job call, but in individual nodes of that cluster. For example, here you see that we are setting one test within that cluster, we referenced by this colon wicked basic ref, plus equal, so we are adding a worker class. And for the second one in this cluster, colon wicked basic stat plus equal, we are adding the value worker bar. So we are ensuring that one job runs on and another one on worker bar. By that, can tweak those tests, can add custom test variables. You can also set custom restrictions for the worker class. For example, in this case, one can run tests which are, specifically verifying a certain combination of workers. There's also a section to start test VMs manually where you could interactively check and debug certain things. And then you need to configure the network manually. And there are steps for debugging the configurations. More commands in here. For example, the one which helped us in the last instance was actually the OBS app control STP show. That's showing the STP information. STP as the how's it called, the simple planning protocol or something, where when you have as in our case we have kernels connecting multiple machines in a star infrastructure, and then we're relying on STP to prevent any kind of loop that's set up. And this one shows how this is handled on the level of it. In OpenGate and OpenGate use scenario definition instead of job group templates. Now that one I will also like to show. we have just taken a look at the OpenK and OpenK test. So let's take a look again. And if you take a look into the job group, then you can see that by now we don't have any scenario definitions necessary anymore in the OpenK web interface. That means those OpenK and OpenK tests could be run on any OpenK instance with a complete set without any further preparation of the OpenK instance. How does that work? Well, that works because we have the complete scenario definitions in this file here. That's part of the test distribution. We are defining the products here, defining the machine. We are using the YAML features to prevent unnecessary application. And here we have a definition of. And this could be used by other test distributions that's fully supported by OpenK. And that allows both to define the settings in a YAML file as well as not need to rely on any web UI. It is possible to track that in Git, but commonly it's done like in a separate Git repo, and then it's not really linked to the change that you're doing. And this way it's much more aligned. Especially helpful for small distributions, but for bigger ones, of course, you can also layer that off with Git submodules into separate, if not directories, other Git reports. So yeah, we prepared the HTTP DNS config for multiple machines, and then we use the data centers to help our IT bring up the it's quicker. And so that's it about the resolve task. Any questions or additions for the resolve task? Okay. So then actually I would like to show you what's currently in the backlog. So in our backlog, we have 6 are in feedback. So I mentioned we are more sensitive regarding multi-machine test failures. So that's another one where we had been alerted by we are looking by those machines fail and always trying to come up with at least a little bit of an improvement there. Also related to that, we still feel like we within the tools team can get a bit better experience of what's actually going on in that network setup. So here we have a Spike solution, Timebox, basically a task, the primary goal that the team gets more experience with retunnels, top devices, and running ping from one node to we also have some improvements that we identified from our retrospective. So building games, like not that much effort, not time consuming, and I find a better plan conducting. Also, what's planned is that there are workshops and meetings planned with the recent growth of the department by the group. We would like to get to know each other better, like to present OpenK, provide support for knowing and understanding what OpenK is usable for, and if it's applicable for this certification cases. And that's part of a workshop. Currently in progress is Dominic is enabling slow roll tests, helping mostly Bernhard Wiedemann. That process. We are having Tina, and actually all Tina and Dominic were both them. So we did not only prepare for some talks, so right now she's also preparing to give them. But we wanted to make that explicit on our backlog to know what we are unifying the GitHub action for QA projects. That's helping us to have a better quality in the code that we maintain, but also it helps so that we can provide better template reports when you start a new project within the ecosystem. That could be, for example, when you create an OS ordinance wheel, so one of those plugins where you extract test code or add an additional, or it could be a new test distribution. And more about caching Git. So we have another spike time box. What else is planned? We have 18 workable tasks. We want to compile a complete list as of now. What packages of OpenGain OS ordinance and dependencies are not currently USL? Because I already mentioned Lee and package up. That's what works. We want to have automated tests, guarantee that we have a long-term support and we can really keep that running with minimum. We already submitted some dependencies where we needed an update or where we needed the package here as a new one. In some other cases, we are still missing some. So to prepare a structured dependency, we are triggering OpenGate as mentioned on GitHub description, and then later on based on comments. That can be done on the yeah, then there's also more work on OpenQA Investigate. OpenQA Investigate is this tool which automatically yeah, that's the query. Let's find a recent example. Any investigate job will do. From here, I'm going back to origin job. And let's see what example do we have here. Right. So what we see here is that we are OpenGate Investigate automatically triggers jobs. There was one addition here lately, which is that last good test and build job is now restricted, run only on the very same worker class command original, rule out any impact of faulty worker. And what we can see here is that based on a combination of those, so Investigate thinks that this is likely a test issue. Because if you go back to the last good test, it works. If you retry it consistently, it helps. If you go back to the last good builds, that doesn't help. It only helps if you go back to the last set, which is helpful. Of course, it says likely, because it could still be a combination of sporadic issues. That's something that needs to be ruled out by reviewers. And another case would be based on this combination that it might be an infrastructure, and that we would like to cover next. So based on calculate and then derive something is likely infrastructure. All of that is also a prerequisite so that we can go further later to use their feedback from OpenGate Investigated to automatically inform kernel resources like on GitHub pull request, open tickets, and read out automatically failing tests. For that, OpenGate Investigate needs to become a bit more smarter, a bit more reliable, so that the result is, has a higher chance to be correct. And then we would propagate that information to other systems. Like if it's a test issue and we identify that this would be maybe one pull request that could have caused that, we could mention that information directly on the pull request. If we have something else, like an infrastructure issue, we could automatically open a ticket. If we identify that we have sporadic failures, then we could, based on what your preferences as or owners of the test products would be, we could also say maybe sporadic failures are acceptable for the acceptance of the product that you want to test. However, you still would like to record that there are sporadic issues, like reported tickets to improve the test or make the classification more reliable in such cases. What else? Yeah, some setup of more machines. If looking further than the current backlog, then we would go into the query of next. That is the staging rows for next task to be picked into the backlog. For example, starting from the top, there's a feature request to optionally restrict multi-machine jobs to a single worker, which would be useful mostly for debugging, where it would be, I mean, it's already possible to just say run those tests on this worker, but maybe you don't want to say which worker, just to make sure that the complete cluster runs on one specific, maybe for certain performance reasons, but mostly for debugging. What else? Yeah, thinking about UML or doc-like design documentation for us audience, so that we can give an easier picture for anyone contribute there. Right, I can mention that one. Batch commenting on all OpenGate jobs involving a specified sleep maintenance incident web UI. So this is like combination of multiple features where you would say, I want to comment on multiple jobs. That's already possible with a shell script. But I would like to identify a specified sleep maintenance incident. That's one example. How it would work is by looking up which jobs have a certain key and value combination in the settings and using that list, commenting on those. Plus, it needs to happen in the web UI. So, you know, a fancy entry field on the web UI to make that convenient and accessible would be a combination of those three features. And that's why Spike solution, a timebox task with no guarantee that this feature would be complete, but we are limiting our time to actually have a better estimate of which areas that would involve and how would an actual feature implementation look. Speaking from experience, there's a high chance that out of Spike solution and timebox tasks afterwards, we will pick an according feature implementation into the backlog because, you know, after the first baby steps are done, often the team is confident that we can actually implement the feature with a sensible effort. But it could be that we identify that this is something that we cannot follow up immediately, right? Yeah, and that's it. Enough from my side. With that, I can give it to you. I know that the audience is a bit smaller today, but still, if you have any questions, note or additions, feel free to pick up. If not, then you still have a chance to talk to me after this call, same room. I just like to point out that what we, thank you, what we have planned for the next topic. So I already said in 2 weeks from now, visit us to learn more about to allow to search for tests by comment on the UI. In the meantime, next week, what we plan to do is to, I would like to talk about the Agile Manifesto because Agile project management is something that I really like and I'm also like to talk about. And here I would like to visit the Agile Manifesto with you guys and also put our team in relation to that. Like, how are we faring related to the manifesto? And review what we do there, and maybe there's some points where others could learn from us, or maybe there are also some points where we could learn how to. Yeah. With that, thank you for your attendance and hope again next time.